Hello students, in this video I am going to discuss IO organization. That is a new module. This was what the outline of this module. We are going to see what are the different peripheral devices. Then there is a concept of input output interface, asynchronous data transfer, data transfer modes of transfer, the priority interrupt, then DMA, direct memory access, IO processor and serial communication. We know in our system, in our day-to-day life, whenever we use a computer system, then what are the different peripheral devices are available with the system that we know. We have a basic idea. So basic input devices are like keyboard, optical input devices such as card reader and paper tape reader, barcode reader, digitizer or optical mark reader. Some of the magnetic input devices like magnetic strip readers, and some of the screen input devices, let's say we use a touch screen or light pen, mouse and other things. And there are some analog input devices. The same way we have different output devices like card puncher, paper tape puncher, CRT, no, that the display, the monitor that we use. In printer, that is also an output device, impact inkjet, plotter, analog output devices which display some analog signals, whereas voice or speakers or other things that we have. Now see, there are a number of peripheral devices which are connected with CPU. So whenever CPU wants to communicate with that peripheral devices, so when a CPU wants to communicate with peripheral devices, for every IO transfer, CPU needs to communicate with the devices. Like let's say CPU want to read something, let's say CPU want to take input from the user, so there are some input devices which are going to provide input. So that inputs are going to be stored inside a memory which is available in the processor, or other memories like what we have secondary storage and those things. So every information which is coming from the outside world to the computers are through input devices. So CPU need to manage these things. Okay, so all those informations are coming from the peripheral devices, IO peripheral devices. So CPU needs to manage that thing. Or let's say if CPU wants to give some informations to outside world, okay, so CPU need to communicate, or CPU need to transfer those informations to the output devices which will display them to the user. Okay, so we have a number of output devices. Let's say if CPU wants to display something, it sends some transport the data to the peripheral device or the monitors or other output devices, speakers and other things. Let's say printer. So if you want to print something, we give a control signals to the print of a particular document. Okay, so what CPU will do is CPU will give or transfer that control, our job, that printing job, to the printer. Okay, so then whenever the printer is free, then printer is going to receive those informations, and then so that there kind of the communications are there. There must be some communication to in between processor and all the IO devices. Okay, so we are going to understand what is the interface. We require some interface in between CPU, because we have a different concept of CPU. We know what is the we know, but we have a basic idea that the processor, the access speed and the processing speed of processor is much higher as compared to other devices like say memory and other devices. Whatever the devices, the peripheral devices, other things, processing speed of processor or CPU is highest among all these devices, right? So we have that basic concept. We will we'll see, if we have a different small peripheral devices, then there are some limitations in terms of processing speed and other things. So we need to take care of this thing. We need to provide some interface. When we are going to provide a communication between, our computer system is going to provide a communication between CPU and peripheral devices. So at that time there is a need to provide some kind of synchronization, or there is a need of some interface between them. Fine. So what is interface? That what is IO interface? Input and output interface. Okay, so interface provides a method for transferring information between internal storage such as the memory and CPU registers and the external IO devices. Okay, so what interface will do is interface will provide a method for transferring information between internal storage and the IO peripheral devices. Okay, so what kind of method? Why there is a need to provide this kind of transferring information method for transferring information? So there are some differences between computer and peripheral devices that we must understand. Let's say peripheral devices are what? Peripheral devices are electromechanical devices. So their mechanism is completely different as compared to CPU and memory, which is electronic devices. Okay, so we have different peripheral devices. All those peripheral devices are operating on some different way. They are working with different data. They are working on the basis of different information. Okay, their capacity, their transfer speed and other things are different as compared to the CPU and memory, which is working on it's an electronic device which work on the different information. Okay, so the data transfer rate is different. For in terms of peripheral it is usually slower as compared to the CPU and other things, right? And CPU or memory which having a faster data transfer rate. Okay, so some kinds of information mechanism we require in between them whenever we perform some data transfer between CPU and peripheral devices, some kind of synchronization mechanism, because the transferring speed of CPU is very high as compared to the receiving speed of peripheral device. Let's say if CPU wants to give something to the output devices, okay, so CPU can transfer the data at very fast speed as compared to the output device which can receive it. Okay, so if the receiver is not receiving those enough information at the same rate, then there will be a problem. No, not already the information is going to be received. As the same way, if input devices is slower in transfer, so as compared to receiving speed of processor can receive those information in much faster way. But if the CPU or the input device is not transferring those information at the rate of receiving speed of CPU, so CPU need to wait until the complete information source. So it slow down your execution speed or processing speed of the CPU, right? So there is a way we require some kind of synchronization in between a processor and peripheral devices. Okay, so for that reason there is a point concept of interface which comes. Even though there is a difference in unit of information, let's say peripheral devices basically works on byte and blocks, whereas CPU works with the word. Okay, so data representation may different. Okay, both the cases, CPU and peripheral device, it may represent a different data types or different data. Okay, so we'll discuss in this video we'll discuss interface module. What is interface module? So IO bus is an interface module. Let's say this is a figure. This diagram shows the internal structure or basic structure of how the processors are connected with different peripheral devices. So in this case we have a processor. Processor is commonly is having IO bus and memory buses, right? So in this diagram we are discussing what IO buses. So let's say in IO buses there are three different buses, that is data, address and control. On data bus, the data your data is going to be traveled. On address bus, the address which is for which the data is associated, that data that information will travel through address bus, and some of the control signals are going to travel from the control bus, right? So in just a general scenario, let's assume that this is the processor with three common bus, and there are four no peripheral devices. Let's say keyboard and display terminal is there, which is a peripheral device. The printer, that is an output device. Magnetic tape, these all are the different peripheral devices. Let's say now in just and giving I'm just giving you an example. Let's say if let's say processor want to communicate with printer. Okay, so the printer, as we discussed, they have different things like processor. The data transfer rate of processor is much faster than the data transfer rate of printer, right? So we need to provide some kind of mechanism to or some kind of synchronization mechanism to handle this differences. Let's say processor is working with the word, whereas printer is going to print something. Let's say different printers are available, dot matrix printer and inkjet printers, and different printers are available in the market, right? All those printers are working on different character sets. Okay, so the information which is coming from processor need to be converted, need to be synchronized with the printer, the printer data or the information on which the printer is working, right? So there is some kind of synchronization which is needed. So you can see here in this diagram, processor and each peripheral devices, there is an interface in between them. So we can say that each peripheral devices are connected with the interface. So there is a separate dedicated interface which is available for each peripheral device. Okay, so processor is connected with their peripheral devices via interface. So there is an interface which is used to solve the difference between, so to solve the difference, to provide a synchronization, to do some of the things, which is, let's say in this case, if we have an interface, so what the benefit of interface is, the interface will communicate with processor based on its own speed. Let's say the interface will communicate with processor based on its own data rate and other things, data transfer rate. Okay, and the same way interface will communicate with peripheral devices based on their own requirement, right? So if the transfer speed of the peripheral device is slow, so interface will communicate with this peripheral devices at that own rate, at the data rate that is that is available for the peripheral devices. The same way interface will communicate with processor based on the, because comparatively processors transfer rate of processor is high, so interface will communicate with processor at the high transfer rate, as interface will communicate with the peripheral devices with their low transfer rate. Okay, the same way there is a difference between character coding and other things, data information which on which this peripheral device and processor work, so it resolves those kind of differences as well. Okay, so we require that kind of interface mechanism. Okay, so each peripheral has an interface module associated with it. Okay, so interface, what is the interface? It decodes the device address, then decodes the command, for which 4 types of basic command that we'll see, then synchronize the data flow and supervise the data transfer rate between peripheral and CPU devices. Let's say CPU, if processor wants to communicate with the printer, okay, so it's not like let's say processor is issuing some command for the printer. Okay, so the data which needs to be print is there available on the data bus, then processor want to communicate. Out of this, all are the IO devices which are connected to the processor. Now processor wants to communicate with which peripheral device, the address of that peripheral device is available with the address line. Okay, so in this case, let's say for example, let's say processor want to communicate with printer, so processor will issue a data bus, data on a data bus, it issue the address of printer on this address line, so the interface module of this which is associated with printer will receive that address. Okay, and it opens a path between printer and this, and the control informations, different types of control informations are available. Okay, so we'll see what are the different control signals are available. Okay, so those information is going to be passed to the IO buses. Okay, and based on the availability of printer, the information is going to be processed. Okay, now there are basically 4 types of IO command that is received through command control line. That is the control command to activate the peripheral and to inform what to do. Then status command to test various status condition. Let's say if let's say processor want to communicate with printer, and first printer is right now busy, let's say before issuing the current, some more jobs are already pending where printer is printing these things. So if the printer is busy with another job, okay, so status command or status bit is not set, that printer is not available right now. So what this kind of things are handled by interface. Let's say interface will handle these things. Let's say if processor wants to print another job, okay, so that request will go to interface first. That request will go to the interface of printer, and in that interface there are some registers which indicate processor that the right now presently the printer is not available, or printer is busy with another things, another job. So processor needs to wait right at that time until the status condition is not changed. That means what, the status of printer is not ready for the processing of a new job, processor needs to wait. So that type of communication, that type of information is available inside an interface, right? So to know that kind of status condition, there is a status command which is issued. So what CPU will do, CPU will issue the status command. So if the status command, when it issue the status command, it will go to that command will go received by the particular interface, and it will give the status informations to the CPU, that whether the printer is busy or not, right? So if the printer is not busy, if the printer is ready to ready to process the new job, then processor will issue an output command, data output command to the through the command line, so that it causes the interface to respond by transferring data from the bus into one of its registers. So whenever the interface will receive an output command from the processor through a data line, so what interface will do, whatever the data is available on the data bus, interface will put those data from the data bus to its own register. Okay, so after putting those data into own registers, it will transfer that data to the peripheral device output devices based on its based on the transfer rate. So whenever there is a requirement of input, the same will be there. Okay, it will check the status, and if data is available, then processor will issue the input command. That means what, processor is ready to take input, so that is input command will go to the interface. So what interface will do, interface will have already taken those data from peripheral input devices to its own register, and whenever the CPU the interface will receive an input command from the CPU, then interface will put data on the data bus, and it will that data will go to the CPU. The CPU will receive those data, right? So in this again different control commands are issued by the interface. So there is basically two buses are there. IO buses are required or are there to provide a communication between CPU processor and your peripheral devices. And when CPU wants to communicate with the memory device, that is the main memory or RAM, if CPU wants to communicate with RAM, so there is two separate buses normally used. Normally we have in your computer system. To your CPU is connected to peripheral devices via IO buses, and CPU is connected to a memory devices through memory buses. Okay, now some of the system is having a different mechanism for these buses. So what are the functions of buses? Let's say memory bus is used for information transfer between CPU and memory, whereas IO bus is for information transfer between CPU and IO devices, right? And then that transfer is through IO interface, right? Now there are three ways that computer buses can be used to communicate with the memory and IO. So there are three ways through which these buses can be used. So what kind of mechanisms are used, or what kind of some of the implementation for the buses are available in the different computers are, some of the computers are having uses two separate lines. That means what, one for memory and one for other. So there is a two separate lines. So processor is connected to memory through memory buses. That means if I am talking about bus, then that bus consists of three different lines, right? Data line, address line, and control line. So there is a separate dedicated bus which is available for communication between CPU and memory, and some of the system, so separate for computer to processor to peripheral devices. So use two separate lines, one for memory and other for IO device. Second, use one common bus. So some of the computer system implement these buses in this way, that is, it uses one common bus for both memory and IO, but have separate control lines. So there will be a common bus which is going to be used for both the communication between memory to CPU and memory to IO. So in that case, all two lines are same, that is address and data lines are same. Only there is a two separate control lines. That means what, a bus consists of four lines, two control lines, one address line, and one data line. Okay, so some of the system, so that is also known as isolated IO. That means what, the IO transfers or IO devices are isolated through control lines. So there is a separate dedicated control line which is available for the IO transfer, right? So for the on the control line of memory, there is a read and write command is going to be issued, and on the control line of IO, there is a control signals for IO devices are going to be issued. So there is a dedicated control lines for each IO and memory transfer. And the third one is use one common bus for memory and IO with common control line. So there is only three lines are available: address, data, and control line, and that is also known as an memory mapped IO. So they use one common bus, एक ही बस यूज होती है for memory and IO with common control lines. So everything is common in between IO and memory transfer. Okay, so that is also known as a memory mapped. So what is isolated IO? That means for separate IO, read write control lines is in addition to memory read write control lines available. It separate or isolate memory and IO address spaces. Okay, it isolate memory and IO address spaces. Okay, so there is a separate dedicated control lines are available. So memory address space and IO space address space are isolated. There is a separate IO space and memory space inside a memory, right? That is the distinct input and output instructions. Okay, so in the memory map, a single set of read and write control is line size, so there is no distinction between memory and IO transfer. So everything is on a single basis. Everything is going to be achieved on a single basis. Memory and IO addresses share a common address space. So there is no separate no address space in our memory. In isolated IO, that means what the IO transfer are isolated in terms of memory. That is a separate address space which is available for the IO addresses, IO transfer, and separate addresses are used for. So in memory there is a reserved portion for normal memory operations and different IO operations. Okay. So there is a address, let's say few address ranges for the memory operations only, and few addresses in the memory are reserved for the IO addresses only. So whereas in a memory mapped IO, memory and IO addresses share the common address space. So there is no separate address space which is available for IO and memory. They are going to use a common address space. It reduces memory address range available, fine, and no specific input or output instructions are available. The same memory reference instructions can be used for IO transfer. Okay. So this is what basic example internal structure of interface. On the left hand side there is a CPU, and on the right hand side there are different IO devices, and in between them there is an interface that we have discussed, right? So what is the internal structure of interface? Okay, so these are the interface. What is interface? Interface will resolve the difference between the CPU and IO transfers, right? So it act as an intermediate which will communicate with CPU based on its data transfer or other things, and it communicate with IO devices. It provides some synchronization mechanism when there is an IO transfer available, right? So it's having some timing and control signals where CAS and RS1, RS2 and read and write control. So this is there is a and a timing and control mechanism available where different operations are going to be performed. Let's read, write. Okay, so this read and write signals are there for their internal registers. There is a buffer which is available. Bidirectional bus is available. It is a data bus is available, which provides a data transfer, or data is going to be available to that bus buffer through during the data IO transfer. So there is a internal registers, port A registers which is used for IO data, port B register is also used for IO data. So there is an internal bus which is available inside different registers of an IO interface. Then there is a control register which holds the control information, and there is a status register which give a status condition of different devices, right? So how there are some mechanisms where if you provide this kind of input, then what kind of data, what kind of registers or what kind of chips are selected. Okay, so this is what a mechanism. If there is a CS equal to 1 and RS1 and RS2 register 1 and register 0 equal to 0 0, then port A is going to register. That means what, based on this control information, so data inputs, okay, the different registers are going to be used. So it is based on the requirement of the processor or requirement of the IO devices, where what kind of data is going to be available on that, what kind of data, right? So this is what an internal structures that we have discussed, that whenever CPU wants to communicate with IO devices, its information or data is going to be cooked in this register, one of these registers. Okay, and when the IO device is ready to receive, then interface will transfer their data to the IO devices. Okay, so whenever CPU wants to read some data from the input devices, first that data from the input devices are going to be there inside the interface registers, and when CPU issues some input command, okay, CPU issues some input command to this, so there is a control register which requires receive this input commands from the CPU. When CPU issues some input command to the interface, then interface is going to transfer this data from any of the registers to data to this bidirectional bus, so data bus. So CPU will receive that data from the data bus which is transferred by interface. Okay. So for this video, let me pause here. Okay, in next lecture I will be in next video I will be discussing on this asynchronous data transfer mode and other things related to this IO transfer. Okay, so stay healthy. Goodbye. Thanks for watching the video.